Hello, my dear students. Today I'm going to discuss about BIOT SAVART law. BIOT SAVART law. Student, this law used to determine the magnetic field due to current carrying wire around the wire. You can find the magnetic field, students, at any point. You can find the magnetic field, students, at any point due to current carrying wire. So students, today I am going to discuss the applications of BIOT SAVART law. First of all, let me write the formula of BIOT SAVART law. And the formula of BIOT SAVART law. So you can write the vector formula also, dB vector, okay? dB vector. Suppose this is a current carrying wire taking a small distance dl and current I, okay? And there is a point, think R. The angle between R and dl is theta. And now you're going to find the magnetic field at the point P. And if the direction of current this, you can place your right hand like this. You just holding the wire like this, and the thumb represents the direction of current. Then the rest of the finger represents the direction of magnetic field. So in that side is the left side of the wire, it's coming out, and the right side it get into it. So here will be the comes out means the dot. Everywhere there is a dot magnetic field. You can draw dot magnetic field because the lines comes out, and here the lines insert into the board. That's why you can write cross. Okay. So this is a current carrying wire, current passing like I. The direction, dl small element, r the distance, this is theta. So you can write dB equal to, dB is proportional to I dl, okay, and you can write cross r unit vector by r square, okay. So you know, student, vector unit vector r means what? Vector r by mod value of r. So if you want to place vector r in place of mod unit vector r, so you can write vector r by mod value of r. It means you can write r cube. So this is another form of vector form. Please write down, student, pause the video, write everything. Then after that you can also transform into scalar form for finding the magnitude. So for that, student, you can write dB equal to I dl cross r means sine theta, unit vector r means 1 by r square. So this is the BIOT SAVART law formula, I dl sine theta by r square. Am I right? So actually this is proportional to, directly proportional to. So if you want to place equal to, so you have to write a constant, and the constant is mu naught by 4 pi I dl sine of theta by r square. Here is the constant term mu naught by 4 pi. The value of mu naught by 4 pi is 10 to the power minus 7, then put the unit. And you know the vector dB value, the unit of dB you can write as Tesla. T means Tesla. It's a very famous scientist, you know the name, Tesla. So you remember, this is the formula of BIOT SAVART law, and using this formula, student, you can determine the magnetic field around the current. This is a current conductor. Around the conductor you can determine the magnetic field using this formula. Up to this, I think no problem. I already discussed this thing in the previous video, students. Now we're going to discuss some applications of BIOT SAVART law. So our first application is for a long straight current carrying wire. For a long straight current carrying wire. Number one, long straight current carrying wire, and find the magnetic field due to long straight current carrying wire. Student, first of all, we're going to take for finite wire, okay. So think this is a finite wire, okay, and you have to find out at distance r. This is the point P. You have to find out the magnetic field at point P, distance r. So close these two things. So this is a current carrying wire I. the length of the wire you can take as L, this is R, and this angle take phi 1 and this angle take phi 2. So student, actually by phi 1 and phi 2 we are actually calculating the whole wire, the length of the whole wire. By using this angle, actually we cover the whole wire. So now let me tell you, this is for long straight finite wire. So number 1, for finite wire, for finite wire you can write B is equal to mu naught I by 4 pi, then the distance R, okay, and then you can write sine of phi 1 plus sine of phi 2, okay. Did you get it, student? So this is the formula of magnetic field due to finite wire. Now you tell me, student, if the wire is infinite one, then what happens? This is for finite wire. Now if the wire is infinite one, then, so student, number B, for infinite wire you can write the formula as thing. So if the wire is infinite, then there is a no ending, okay. So here you can close these two things, but if this is infinite, then where it will move, where it will intersect, we don't know. So you can draw like this. So this is called, this is the angle is 90, and in that portion also the angle is 90. So in place of phi 1 and phi 2, student, you can write 90 for infinite wire. So for calculation for infinite wire, you can put phi 1 and phi 2 as 90. So you can write mu naught I by 4 pi R sine of 90 plus sine of 90. Sine 90, sine 91, sine 91, this is also 1, so 1, 1, 2. So you can write mu naught I by 2 pi R. This is for infinite wire. Did you get it, student? So this is for infinite wire. When you see the infinite wire, you can write this formula. This is for finite wire, this is for infinite wire. Now you must be thinking that how you can find the direction of magnetic field. For that, you have to place your right hand, you know. So this is the direction of current. Put your thumb in the direction of current, then the rest of the finger denotes the direction of magnetic field. So here is the dot and here is the cross. So at the point of V, you can draw a cross magnetic field. So cross magnetic field, you know, cross means actually magnetic field get into the board, so it will be inward. You can write as an inward, okay. So this is all about for the current, this for finite wire, so infinite wire. And now think for semi-infinite wire. Student, semi-infinite. So our next application ABC, next application is for semi-infinite wire. So for semi-infinite, student, you can write semi-infinite means what? The lower portion actually off. This is the starting of the wire and it will never ending, means infinite wire, and one side infinite and other side there is a no wire. So you actually find that position P. This is suppose wire and you have to find out P. So in that portion this is going to infinite, and if you want to intersect this, they will never intersect. So phi 1 equal to 90 and there is a no phi 2. So in place of phi 2 you can write 0, student. So phi 1 90, in place of phi 2 there will be 0. Actually we calculating for number C for semi-infinite. For semi-infinite where mu naught I by 4 pi sine 90, then sine 90 means 1, sine 0 means 0. So only mu naught I by 4 pi R. This is for semi-infinite infinite wire. Did you get it, student? So we can see there is a 3 part of applications of current carrying wire, and now the part number 4, D. Student, let's see number D. Suppose there is a situation that you have to find the magnetic field. You have to find the magnetic field at the head of the top of the wire. Suppose this is a wire, okay, and you are going to find out the magnetic field at the top of the wire, means top of the head, okay. So suppose this is a wire, okay, and now there is a point P where you are going to find the magnetic field at the point P. So how much B? So student, you can see the distance R and DL both are in same direction. Say yes. Student, distance R and distance DL both are in same direction. Am I right, student? So in that case, R and DL, the angle between R and DL, how much? 0. Because R and DL are in same direction. So angle phi equal to 0. So in that case, you know the formula sin phi. So actually the BIOT law formula, if you put the BIOT law formula, then number D, right? Number D at the top of the wire, point P. Okay. So for that, you can write B equal to dB equal to mu naught I by 4 pi r sine of theta. Sorry, mu naught I by 4 pi r square ideal sine theta by r square. So in that case, theta equal to how much? Theta equal to, from direct formula you can put theta equal to 0. So theta 0 means sine theta 0. So dB equal to 0. So at the top of the wire, student, dB equal to 0. Okay. So you please prepare for the long straight current carrying wire. Okay. In the next video, I'm going to discuss about the circular part. Okay. In the next video, we're going to discuss about circular wire. For a circular wire, this for the straight wire, long straight, ST means straight, long straight current carrying wire. Now, in the next video, we're going to discuss about the circular wire. Okay. Okay. Thank you so much, student.